Today we're finishing our Pythagorean theorem unit with 8.7d. Your objective today is to be able to determine the distance between 2 points on a coordinate plane using the Pythagorean theorem. Now this looks like it might be a little bit harder because you're dealing with a coordinate grid and points and having to figure out where the different points are and things, but really all you're doing is finding a missing side. It just happens to be on a coordinate grid. So, there's a couple of things that we need to remember. First of all, our formula. Oh, first, let's make sure that you have your full name, today's date as the due date, and you're going to need 3 stamps today to get 100. Okay, so we've got our formula, a squared plus b squared equals c squared. Usually, I'm not going to say always because I don't know for sure, but usually whenever we're determining the distance between 2 points, you're going to be solving for this hypotenuse. And the reason is, if we look down here, it's really easy to count and see how long this side is, and it's really easy to count and see how long this side is. This is the one that you're going to have some trouble with. So this is normally what we're going to be looking for. Maybe not always. So let's look at number 1 together. Let me zoom in here so you can see really clearly. All right, there we go. So, Jason drew a scale map on a coordinate grid to show the location of 3 towns. We have Green, Allenville, and Schouten, or something. Based on the scale of the map, what is the distance from Allenville to Schouten? So, 1 box is 1 square mile, which means that one length would be, this would be 1 mile. Okay, now they haven't given us any numbers here. Don't get confused, it's actually really easy. All we're going to do is count. So the length of this side right here is 8. It goes from 0 up to 8. So that's 8 miles right there. Over here, from Green to Schouten, we have 6 miles. So again, they did not give us these distances, but we can figure it out without any problem. What we're looking for now is the distance from Allenville to Schouten. We want this. And of course, this is our hypotenuse, so it's going to be C. This is our right angle. And now we just solve. So it's really the same exact thing that we were doing yesterday. It's just on a grid. That's all. So let's start solving. A squared plus b squared equals c squared. Let's use 8 for A. 8 squared plus 6 squared equals c squared. So we wrote the formula, then we filled in what we knew, and now we're going to start solving. 8 times 8 is 64. 6 times 6 is 36. And we still don't know anything at all about c. So that just remains c squared. So if we put this in our calculator, 64 plus 36, we get 100, which is a really nice even round number. 100 is c squared, but wait, remember we don't want the square miles, we just want the distance. Okay, again, we're not looking for this whole square that's created over here. We just want the distance from Allenville to Schouten. So we take the square root of both sides. Those cancel out, and I'm left with just c. And the square root of 100 is 10. So c equals 10 miles. We need to put this into our bubble map, our bubble thing. It is positive. We can't have a negative distance here. positive 10 miles. So I'm not going to put 1 0 right here on the end, and I'm not going to put it way over here. 10 has a decimal point right after the 0 because it's a whole number. Anytime you have a whole number, it goes right before the decimal point. And then we have to bubble it. That's the most important part. That's how the machine makes sure that it's reading it correctly. 10 miles. Now if we jump over to the back, I'd like for you to do number 3 before we look at number 2. So go ahead and do number 3 on your own. It's the same thing, same exact process. When you finish number 2 and you have it bubbled, please bring it to me for your stamp, and then we'll go back to number 2 together. Back to number 2. The problem says, the student council at Zimmer High School plans to build large letters to display in their gymnasium to boost school spirit. If they want each letter to be 12 feet tall, use the diagram to determine the length of board needed to build the letter Z. Each line represents 1 foot. Okay, so 12 feet tall. First of all, let's look at our letter here. They did not draw this very well. I actually had to go back and look at the key to see how this was supposed to be drawn. So I'm just going to kind of go over. It should only be 5 feet long at the top and the bottom. And then we just connect both of those. So I'm just going to use a piece of paper here. And then the other problem with this is that it says it's 12 feet tall, but it's actually 13 feet from here to here. But we're going to use the 12. So it's 12 feet tall. They just drew it incorrectly, I guess. So we're going to draw our Z over here. And we know that this is 5, and this is 5. So that's 10 feet right there, because it's not just looking for the length of the hypotenuse. It also, we have to build the whole Z. So the 5 and 5 for the top and bottom are included. And then this, based on what the problem told us, is 12 feet. And so we want to find C, our hypotenuse. Okay, so a squared plus b squared equals c squared. Let's use 5 for A and 12 for B. And we're still looking for C. Five squared is 25. 12 squared is 144. And when we add those together, we're going to get C squared. So let's look at adding those together. 25 plus 144 is 169. And just like every other time, or most other times, we don't want C squared, we just want C. So let's take the square root of both sides, cancel those out to get C. In your calculator, figure out the square root of 169, and we're going to find that it's 13. So C is going to equal 13 feet. Notice that we have an answer choice that says 13 feet. So if all we did, if we didn't read carefully and we just found the hypotenuse, we can be super great mathematicians, but also not be paying very much attention to the problem and still get the problem wrong. So let's read carefully. It says, determine the length of board needed to build the letter Z. And of course, we need board to build the top part and the bottom part, as well as this part. So we have 5 feet plus 5 feet plus the 13 feet for the hypotenuse. That gives us 23 feet, which is our solution. Now don't worry if you get a question on a test or something where the picture's drawn wrong, we will let you know. So if we don't tell you otherwise, then assume that everything in the problem is correct. Please go on now to number 4. That's going to be another bubble question. Notice on number 4 that it says that we're going to figure out the distance from point B to point A, and then to point C, and then back to point B. So we're going from B to A to C and back to B. So we're actually figuring out the whole perimeter of the triangle here. So just read carefully on that one. Okay, we have one more to do together, and that's number 5. Study the picture below. Which of the following best represents the length of D? Okay, so the length of D being this curved not the curved part. We want to find the length of D, which is this line segment here. So we've got a triangle. Here's our right angle, which means that what we're looking for is C. Now we're not given any other numbers other than this point. Point D is at 2, 8. So we can use that. That is enough to help us out. That means that point D is at 1, 2, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. That means that this right here is 2 units, and this right here is 8 units. So all we had to do was just look at this one coordinate that's given to us, because we're starting at 0, 0. So we go to the right 2 and up 8. And now we can solve. Start with your formula. We're going to plug in A and B. Eight squared is 64. 2 squared is 4. When we add those together, we get 68. Again, we know that we need to take the square root of both sides, but before we do that, I want to show you a way to estimate it. If this confuses you, then just tune it out. This is just a way to kind of check your work. So I know that 64, okay, if it were the square root of 64, that would be 8. And then if it were the square root of 81, then it would be 9. So we know that here, the square root of 68 is going to be somewhere in between 8 and 9, which means that I can already get rid of A and C and D. So really, I already know that the answer is B, just by estimating like that. But let's go ahead and put it in our calculator. And I get 8.24. Let's put it back over here on our picture to make sure that it fits. That is the longest side, and it's the biggest number, so that does make sense. And that the best estimate of that is B. So you're going to do the same thing on 6. When you have finished number 6, please bring me your paper for your stamp. Make sure that you have your full heading and everything on your paper so that you can turn it in before you leave today.